Chapter 9, Analysing Data. Okay, the heights of a group of ballet dancers, calculate the mean. Okay, the mean, the average, add up all the scores. So we get 2771, and there are 16 scores. We want it to one decimal place, which is 173.2. Okay, question 2. The speeds, sort this frequency table. Alright, so try to do one as best as possible here. Alright, so we've got our group, our class center, and our frequency. Okay, so we've got 60 to less than 70, 70 to less than 80, 80 to less than 90, and 90 to less than 100. And that's the maximum. Okay, now the class center of 60 to less than 70, well, that really basically includes all but 70, so the average of that is 65, therefore 75, 85, and 95. Now, the frequency. So go through and check all the 60s. So we've got 1, and if you count all the rest, you'll have 7. Then count all the 70s, 13, all the 80s, there's 23, and all the 90s, there are 7. So altogether, there are 50 scores. Now, calculate an estimate for the mean. Okay, so with this, we need to do an fx column, but in this case, it's an f times cc. Now, we could do the actual mean and add up all them and divide by 50, but to an estimate, we're going to use the cc column as the score. So 65 times 7 is 455. Then we've got 975. 85 times 23 is 1955. And 95 times 7 is 665. Add up all those and you get 4050. So therefore the mean will be the estimate for the mean will be 4050 divided by 50, which is approximately 81. Actually, sorry, it is 81 kilometers per hour. Now, the median and the mode for the ballet dancers from question 1. So the mode, the most common, and we see that we have, we've got 170 occurring 3 times, and 168 also occurs 3 times. So both of those will be the mode. So 168 and 170. Now the median, you need to rank them in order. If not in order, then you basically just got to go from cross up the lowest and then the highest and keep on going until you come to the middle scores. So the lowest is, I think, 165, and the highest is 183. And you keep on going that until you get the last 2, which will be 171 and 172. What's the middle of that? It's 171.5. Okay, the dot plot is a die rolled So 2 dice rolled 20 times, find the median and the mode. Okay, the mode is clear, that's 7. It's got the most dots. Now the median. Now you can either cross off the smallest for the largest and then smallest for the next largest and keep on going, or you know there are 20. Now one little thing to find the median position is to n plus 1 over 2, n being the number of scores. So 20 plus 1, which is 21 over 2, gets you the 10.5th score. Now, if you go through from the lowest, and you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next one will be the 11th. So the 10.5th score is in there, which is between 7 and 7 anyway. So therefore, the median is 7. Alright, the house mean price. Okay, add them all up, and you get 3,500,000 over 8 prices, and you get 4,375,000. Now the median, okay, so if you cross off the smallest for the largest, the next smallest for the next largest, the next smallest for the next largest, you're left with these two, and the average of those two, or the middle of those two, you can either add them up, divide by 2, or you can clearly see the middle between 342 and 348 is 345. So that is your median. Alright, is the mean or the median better? Well, the median is better because that is not affected by a big outlier. The mean is affected by an outlier. Okay, which measure a location? So your location is your mode, your mean, or your median. Which one's most appropriate? Okay, the average men's shoe size. Now don't think average means mean necessarily. All of them are averages. So the average men's shoe size, the best one for that is mode. Because you want to probably, if you are owner of a store, you probably want to purchase the most common shoe. The average height of Year 11 students would be mean. The average starting salary of an Australian worker. Now, median, because that's probably affected by big outliers. Okay, in a national maths test, Simone scored 84. This score was above the 7th decile. Approximately what percentage of students taking the test scored lower than her? Okay, she's in the 7th decile. Decile is tens, so that is the 7th 10, which is 70. So therefore, 70% were lower than her. Simone's score was the 87th percentile. What percentile of students scored higher than her? So she's 78th percentile. It is obviously 22 scored higher than her. Now what is the meaning of interquartile range? Well, interquartile range is the range of the middle 50% of scores. Alright, 15 packs of chips were measured. Find the range and interquartile range. Okay, now it's best to put these in order. So I'm going to try and, so 48, 49, 49, 49, 50, 50, 50, 51, 51, 51 and 51, 52 and 53. Okay, so the middle of 15 or you can do 15 plus 1 is 16 divided by 2 is the eighth. So 1, 2, 3, 4, 5, 6, 7. That's the median. Now, so therefore, what's the middle of those scores? Which would be that one there, because we have 3 below it and 3 above it. And same as this, 3 above and 3 below. Okay, so the range is the highest score, which is 53, minus the lowest score, which is 48. And that gets you 5. And the interquartile range, the upper quartile is 51, minus the lower quartile is 49, and that gets us 2. Okay, the stem and leaf. Alright, so we can see that the lowest score is 43, the highest score is 89. Alright, so the range is 89 minus 43, which is 46. Alright, the median. Now, if you count up, there are 20 scores. 20 plus 1, 21, over 2 is 10.5, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the median there, which is between 64 and 65, so 64.5. Now the mode. Now, we can see just here there are 2 5s, and here there are 2 2s. So therefore, the mode is 45 and 72. Now the interquartile range. Okay, the lower half of this, the median is between the 2 and the 7 there, because there's 5 below and 5 above. Now halfway between 2 and 7 is 4.5, so it's 54.5. The other half, which is just there, again 5 below, 5 above, between 2 and 2 is still 2, so that is 72. 72 minus 54.5 is 17.5. Students were surveyed about the number of pair of shoes they owned. Copy the table, add in a CF column, cumulative frequency. Okay, so add up the frequency. So we have 8 initially. You add another 10, we get 18. Add another 9, we have 27. Add another 5, we have 32. And add another 5, we have 37. Okay. Now, draw that a cumulative frequency histogram polygon. So therefore, hopefully with a ruler, go in half a centimetre each. Now we have to start with that half a centimetre gap here. 5, 6, 7, 8, and 9 are our shoe sizes. Now our cumulative frequency goes up to 37. So obviously depends on how long our graph is. So therefore we can go up by 4s, we can go up by 3s, it doesn't really matter. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, and 39. Okay, so that is our cumulative frequency axes, and this is our shoes. Okay, so the score of 5 goes up to 8. No gaps. The score is 6. It goes up to 10 in the frequency, but it goes up to 18 in the cumulative frequency. Then we've got 27. Then we have 32, just a bit below the 33 mark. And then we have 37. Okay, and the polygon, now different from a histogram and polygon for a frequency. Normally a histogram, the polygon goes from the center. We definitely don't want that. It starts from the bottom corner to the opposite corner and then to the next top corner. Okay, so we're going to use a polygon to estimate the median. Okay, so the median, now our score goes up to 37. Now on the graph it's pretty easy. All you need to do for the median is, because half is divided by 2, and you get 18.5. So you go to 18.5, which is just about there on the graph. You go across until you hit the red line and go down, and what score does it hit? And it hits 7. So our median is 7. Now if this was a group data where, say for example, you might go up from 70 to 80, then you actually have to estimate that to, say, hit there as sort of 72 or something like that. Obviously this isn't, so don't worry about that. Alright, now the interquartile range. Okay, so the upper quarter is going to be 3/4 of our 37. So 0.75 times 37 gets us 27.75, which is approximately there. We go across until we hit the red line, and it's down there, which is 8. Now our lower quarter is 1/4 of the 37, which is 9.25. Which is about there, which is equal to 6. So our interquartile range is 8 minus 6, which is 2. Now the third decile is 0.3, again of the 37, which gets us 11.1, which is just probably about there, which again is 6. Okay, the box and whisker. Now remember, box and whisker, this is the lower score, the lower quarter, the median, the upper quarter, and the high score. Okay, so the lower score is 0, the interquartile range, 10 minus 5, which is 5. What fraction of the games were over 8 goals? So over 8 goals, well that includes 25% and another 25, so we're talking about 50%, which is half. What percentage of games were less than 5? So we're talking about that, which is 25%. Okay, create a 5-figure summary for a chip packet in 8b. Now we don't actually have 8b here, but a 5-figure summary will just be the lowest score, the lower quarter, the median, the upper quarter, and the highest score. They're your 5 figures. Sometimes you put them 1, 2, 3, 4, 5. Now, if you're representing another box and whisker, you get your ruler and you just measure your line, obviously starting probably at the lowest quarter, sorry, the lowest score going up to highest score, and just basically draw in your box and whisker in accordance to that. Okay, for the quality test, they take a random sample of 10 screws. Each design have a length of 2 centimeters. The actual length of the screws in centimeters are, okay. So, find the mean. Alright, normally you could just add them up, but because B says find the standard deviation, you might as well use your calculator. So, we need mode on your calculator, SD, and the 0. Okay, because we're only doing by univariate data. Okay, just one set of data, not line. Okay, so you get calculator, and the mean, which is alpha 4, would be 1.998. Now the standard deviation, which is alpha 6, 0.2. Obviously with the other calculator, you just have to put it into the table and just make sure your frequency is off, and then you use your second functional shift stat, which is down near the 2, and you find those two symbols. Now 14, the shoe data from question 10. Okay, now it's in a table, so again we'd clear our data, so second function alpha, and we would use then stow. So you'd put a pair of shoes 5, 8 people had that, so you do 5 stow 8 m plus, 6 stow 11, sorry 6 stow 10 m plus, 7 stow 9 m plus, 8 stow 5 m plus, 9 stow 5 m plus, and do the same thing alpha 4, which is 6.7, and alpha 6, which is 1.3. Now on the other calculator, this time you've got to make sure that your frequency is on, and then you go to, you add them, you put them all in, you AC it at the end, and then you go shift stat, and you var, and you find those. Alright, when taking samples from a population to estimate statistics, what are 2 ways of improving the estimates? Obviously random is a good way, and if you do more in your sample. The smaller the sample, the less the results are accurate.